Hi everyone, this is John Wan. Today is May 20, 2020. I will record this video to briefly go through what I've been done in past few weeks. Since it's been a while, I haven't recorded the video for the weekly report. You can see from the progress bar for the first item. The last time we estimated 18% of work has been done by the end of the last time we record the video, and during the past few weeks I estimate maybe we have accomplished 12% more on this extended survey to journal version. So I will go through the detail on how we make it. But firstly, I hope to let you know we have already successfully submitted the camera-ready version of the survey for the final submit, which is submitted to the 2020 SCC IEEE conference. And I would like to thanks to Dr. Liu and Dr. Che because of their help, dedicated help. The paper is growing better and better until the end. I think the paper is very enjoyable to read and it's very good fine grain paper. So I try to read multiple times and I think it's very enjoyable, and also try to fix all the typos, all the sentence that does not make sense. So we're trying to make a good piece of work for future readers for the reference. So this is, I think we have a period for this item. And for the next item, which is we are currently working on, is to extend this survey to a journal version. So for the past few weeks, I keep reading the survey in a slow pace. Every week I read one paper, and there's no exception during past week as well. I worked on the survey 8, so I think this is a survey A paper, and this is a paper submitted in 2020, January 28th, to the archive. So I think it's a paper with very fancy keywords in the title. You can see from here it's reinforcement learning-based auto-scaling of the workflows in the cloud. But basically, if you go through the whole paper, you will find out basically it just talk about the workflow scheduling, but it's separate into two parts. The first part is provisioning, and the second part is actual scheduling. So the words reinforcement learning is basically includes two categories. One is a static, one is a dynamic. As we said, the static is a scheduling that happens before the execution, and dynamic is an interleave between the execution and to the real-time or real-in-time scheduling during the runtime. So that is the difference. But I think these keywords may be not that correct to put here, because if you can see from his, I think he has a graph to illustrate the categorization. So here you can see for the reinforcement techniques, the author includes a dynamic programming and temporal difference, and there's a typo. There are many typos in this paper. That's one thing we need to make sure maybe can be improved in this paper. But here, I do believe the dynamic programming should not be included in the reinforcement learning techniques, because this is a basic algorithm in algorithm category. So I think it's a kind of top-down, the bottom-up approach to solve a specific problem, but there's no kind of reinforcement learning involves in pure dynamic programming, so it should not be included in this category. If you read this paper carefully, you will notice that the dynamic programming is basically a kind of static scheduling that happens before the execution. On the other hand, the temporal difference is more prone to talk about the dynamic programming, which is happening during the runtime. So you can see there, like the sequential learning, like the parallel learning, they're trying to give some dynamic feedbacks to the scheduling. So that is help to schedule the workflow during the runtime. And there are other ways like the neural network and fuzzy logic. So I think there are a lot of misunderstanding in this paper, as well as I think there are some mistakes. For example, in the Formula 1, I do believe the formula for the mixed band is quite confusing and most likely is not correct, because you can see the mixed band is only applied on one of the tasks, that maximum plus the which one is I think this is unknown beforehand for dt, and minus the one that is the early start time. So I think there also need to make sure that the provisioning time, because the provisioning is also talked about in this paper. So provisioning time also need to be considered in this mixed band. But also for now it is still confusing for many people. So I think this T and this T is different, and they have to loop through all the T's, right? And there's not only specifically tied to one T. So that's a thing for this one. So I think overall this paper is these big improvement or major improvements, and also I think this paper, the only thing this paper reminding me is about the reinforcement learning. Maybe we can really potential apply this reinforcement learning in workflow management system in some way or somehow. So I think it's a kind of help that while I read this paper. So this is the first item, and also I try to outline the structure of the extended survey to the journal version based on the current shape we have. So you can see here I have a structure outlined like this. I hope to discuss with Dr. Lu and Dr. Che maybe during the meeting today and ask for some feedbacks. So here you can see the first part I didn't change too much. Basically the first part is mainly talk about the workflow scheduling. Firstly, we introduce a problem, the challenge, the taxonomy based on what we have. And the second part is we are going to go through or list out some representative algorithm currently based on our taxonomy, and maybe we can add some more algorithm in each category for this part. And the second part is mainly focused on the scientific workflow management system. So similarly, firstly we will discuss like here we have the problem, challenge, taxonomy, and here we have several things to talk about as well. The first is the goal of the scientific workflow management system, and then the requirements, and then the challenge. So each one I list out some of them. Maybe we can discuss them during the meeting as well. For example, for the scientific workflow system, the goal I list out several. For example, like the automate the workflow execution according to the scheduling plan, and then conform the service level agreement, as well as quality of service. And then another goal is to real-time monitor the execution. And then we also need a kind of failure handling and a partial workflow execution, because the dynamic of the cloud computing that make us this is a goal as well. And then we have requirements. So the requirements is like customize a user-friendly UI, and then the reproducibility with provenance data, and then the interoperability between the multi parties, like they want to cooperate among several institutions in different geographical location. So that is one thing. That is one requirement for current scientific workflow management system. So maybe we can add more, and we can get more like what I missed. Maybe we can discuss that in the meeting. And also, next is a challenge of the workflow system in the cloud. For example, like the cloud performance fluctuation, that is performance is different time from time, even on the same resources, because depends on the demands of or the usage of the whole cloud. For example, now there are hundreds of users are using the same data center or a same subset of the data center, so that will cause a lot of traffic and will cause a lot of delay. But if there's nobody using current data center, maybe it will be super fast. Like if you're running a computer, there's no heavy workloads, the program will run very fast. But if there's a heavyweight program is ongoing on backend, you always feel the legacy when you open a program, when you open something. So that's a way similar to this problem. Also, we have the shimming problem, and then we have the system security and the integrity problem, as well as we have enormous data set, real-time processing challenges. So these are part of them from my qualified exam. So I think the ideas still be applicable for this journal version. So I just put them here. And then the second part of the scientific workflow system is still we are listing out some representative scientific workflow management system here. Maybe I can add a few more to enrich this content. And the last section, we are going to discuss the role of AI in scientific workflow management system, and this part we still need to refine a little bit, maybe after I get some feedback from Dr. Lu and Dr. Che. So this is almost all I've been done for the past week. So I think it's pretty we made pretty good progress so far, especially the first paper I've submitted for the PhD study. So I think that's quite a milestone. That's very good. Hope the next paper will come out more smooth, and the quality will be better and better. So thank you so much for your time for watching this video, and hope you enjoy it. Until next time, happy coding.